glad to have you here. I'll be honest, the sessions that we have this morning at breakfast and at lunch are the ones that I've been looking forward personally the most. And part of that is that for the last few years, I've served on the board for our local affiliate of Habitat for Humanity. And you'll get to hear a little bit more about that story at our lunch session. But we've been using prefabricated components for our builds since COVID. And it's really been transformational in what our affiliate has been able to do and how it's been received by the community. And so our goal today, you'll see we've kind of got two parts. We've got this morning session, which is about incremental utilization. So how do you start dipping your toes into using this? And then at lunch today, we're going to talk about, okay, are you ready to go all in, whole hog into this? So we have a lot of the same panelists across both of them. Before we do introductions of our panel speakers today, I'm curious how many of you here in the room have already started to dip your toes into using prefabricated components, modular. Okay. Yeah, so we've got a few of you. I'm curious, for those of you that haven't, to kind of give us a framework so that we can see what concerns we need to address today. What is it that has kept you from using this in the past? And if we can get the microphone ready here, just for any of you that are willing to share, what is it that has kept you from dabbling in using prefabricated components and panels in the past? So we'll start right here.
We're down in Southwest Florida, so wind codes and insulation requirements mainly. We use block construction, so if there is prefab components out there that can meet those needs, then we would love to look into it more.
Okay, we can address that. What else? Other concerns or questions as to why you have not started to dabble in prefabricated components? Anyone else willing to share? Yes, over here.
So we're in Atlanta, and pretty much everybody who's done it in Atlanta has done it unsuccessfully. Companies come in and out. I did it in Charlotte for a couple of years.
Can you elaborate on what unsuccessful looked like for them?
Not having the right trade partners.
What was that?
Not having the right trade partners.
Not having the right training partners, okay.
Yeah, we did it in Charlotte. We had framers fighting with 84 lumber, no consistency. One of the biggest issues we had was if the slabs weren't correct, they're out there with sledgehammers beating things into place.
Okay.
And we just did not find, we didn't save the time that we were should, because you're going to pay more up front. If you're not saving the time, it's kind of useless. We just could not make it work with the trade partners we had.
Okay, good. I think those are useful points of reference. Anyone else willing to share what might have kept you? Or I think this is a good example. If you've seen others in your markets who have tried, what didn't work for them that maybe you're like, yeah, I'm going to pass on that. Okay, I think that's a good start. Something we can work with today, right? Okay, so let's as we turn over to here, let's do introductions of our wonderful panel we've got today. Now, I will put an asterisk here. You'll see that we're missing one individual here, and they're not joining on pre-recorded. Michael Gibson in the bottom right is actually a fellow faculty member of mine at K-State. He's worked on the Habitat for Humanity project that I was just referencing. He wasn't able to be here for the whole conference. His intent was to fly in last night, and of course, as luck would have it, his flight got pushed back, and so he's on a morning flight. He's going to miss this morning, but he should be here for lunch. So we'll get to catch up on some of his input as a professor of architecture. He'll certainly be able to talk about some of the design challenges, but probably more what the foundation you need to put in place. But with that as a foundation, let's begin with Dave. Can Dave tell us about yourself and about your company?
Hi, good morning, everybody. My name is Dave Stevenson. I am the sales manager for InsulSpan structural insulated panels. I actually have two roles at the company. One is sales manager, but with my construction background, I find myself on the job site a lot doing site advisory services. And anyhow, InsulSpan manufactures SIPs, structural insulated panels. We have two locations, one in Blissfield, Michigan, and the other just up the I-5 here across the border near Vancouver, British Columbia. So it was an easy trip down here for me today. That's what we do, structural insulated panels.
Okay, next on our panel, Jason.
Hello, Jason Carter with Vantum Global. We manufacture a similar system. It's a SIPS, but I like to use the term SIPS on steroids. We have a non-combustible, waterproof, fireproof, nano ceramic SIP. We built about 3 million square feet in South America. We recently received an investment from Breakthrough Energy Ventures, a $1 billion fund created by the Bill and Melinda Gates Foundation to lower the carbon footprint, and they chose us as a housing solution. Our goal is to build 15 factories here in the United States with partner developers. Glad to be here and hope to answer all your questions.
And last up, Ken.
My name is Ken Pinto. I own a supply chain consulting firm called Kenzai USA. Kenzai is the Japanese word for building materials. In Japanese language, Ken means construction and Zai means products. I was born for this, right? So after decades of being a manager of construction, both commercial and residential, I discovered that not having the right materials in the right place at the right time was prevented me from improving my construction operations. And so I got out of operations with intent to go into supply chain, fix that, and then I'd go back into operations. I vastly underestimated the size of that task, and I'm still in supply chain. And so much so that I last 12 months ago, I wrote a book, How Much is the Milk, which is a supply chain management book specifically for residential construction. The only one of its kind. There should be dozens of books like that in our industry, but there isn't. There's only one. I'm not sure why a carpenter like me had to write it, but I had to write it. So, and as a matter of fact, I brought this with me, and so those who ask the best question will get this book today. This is a little giveaway for today. Very subjective process in which we will award someone a book signed by the author. And I started using wall panels and roof trusses in 1979. So when I was a junior in high school, I built 5 houses my last 2 years of high school. And Latham Lumber Company in Sacramento, California, was making wall panels. And I don't know if they were the first to do it, but we didn't know of anybody else who was doing it. And boy, we sure built those houses fast.
There are some benefits. So to start off, we're going to talk a little bit about what do prefab panels, SIPs look like, and there's certainly a spectrum. The pictures you see here come from the build at our local Habitat for Humanity, where the prefab panels were done by Kansas State students under Michael Gibson's tutelage, where the panels are put together and then brought to a site about 5 miles away, and then the panels were lifted. And I've got some more pictures and videos that we'll see at lunch for this particular build. But as I show these photos to Dave, he looks at it, he's like, that's nothing like what our SIPs look like. And then when you look at what Jason's company is doing, really doesn't necessarily look exactly like what Dave is looking at. So I want to give everyone here a chance to talk about kind of their flavor, but really what they are, how they're made, and then we'll start talking about some benefits and stuff. So we can kind of work our way down the table. Dave, you want to start off?
Sure. Well, what do prefab panels look like today? I guess in terms of how they looked yesterday, there's a lot more technology going into the panel manufacturing process now. Most of the panel design is with 3D CAD modeling. Those CAD drawings are then programmed into a CNC cutter, and the panels are typically cut with CNC fabrication techniques. So they've come a long way over the last, say, 10 to 20 years. The panels do look different depending on the manufacturer and the type of panel. We do what are called typically what most people would refer to as SIP panels, stress skin or structural insulated panels. It's just really 2 layers of sheathing inside and out with a insulated core laminated to the sheathing, and then those panels are cut on a Hundegger PBA machine that to any shape or size and sent to the panels to be tilted up and clicked together.
And when you say sheeting, what is the sheeting?
In our particular case, we use 2 sheets of 8x24 OSB sheathing on the interior and exterior side of the panel with a EPS core. That core can be of various thicknesses, and there's 2 types. There's the regular type 1 EPS that most people would associate with a SIP panel, just that white EPS core. More recently, they've begun to infuse carbon, basically carbon into the foam to increase the R value. It comes out looking almost dark gray or charcoal, and is referred to sometimes as neopore or GPS foam.
Okay. Ken, tell us a bit about your experience with talking about SIPs. What of the ones you've worked with look like, and was there anything you'd want to add specifically to what Dave described?
I've never made a panel, but I have bought a lot of panels. And so from the acquisition side of the business, there's a few reasons why we want to do it. One is speed to market. All right, so you want to reduce the construction cycle time. You can do it with houses. Let me give you an example. So when I was with Pulte Homes, we built a community in Southern California called Sun City Shadow Hills. 5,000 houses in that community. And so we had our framer set up a panel plant, which we invested with him on that, significant investment. Pretty short distance drive, which is a key part of this panel business, from the manufacturing plant to the job site. And when you have 5,000 houses to build it all in one plant, you can make a lot of money with that speed to market as well as the efficiency of getting those panels done. And quality is another issue. Quality is a big one. I mean, I'm old enough that I've been on job sites now for more than 4 decades. And I can tell you that the quality of craftsmanship in the field is not getting better. My hat is off to all the organizations that are striving to take high school graduates and teach them trades. And my hat is off to them. I applaud the effort, but I don't have confidence in the effort. There's not enough people in those programs to be able to support what we're going to need over the next 10 years. You know, you look at the number of people who are in our industry who are craftsmen who are going to be retiring over the next 10 years, and there's no solution for backfilling them. So I think that we look today at panels as an option. From my perspective, I don't think it's going to be an option. I don't think there's going to be, I don't think you're going to have a whole bunch of framers who are going to be available to frame your houses 10 years from now. So it's looking pretty doomed. So not only the availability of the labor, but the quality of labor is really going to be tough. And when you have factory-made panels, your quality level just soars. If you want to show a homeowner the difference between a house that was made with panels in a factory and one that was framed in the field, just walk them into one framed house and another framed house, and instantly they're going to see the difference. So the precision of the way that things go together, they're going to be like, oh, wow, that's different.
Okay. Jason, tell us a bit about what you guys are manufacturing. I think I've got a slide here that kind of shows some of the construction as well.
Thank you, Dave. I don't want to talk too much about the hog, but I hope all of you come to the next panel that we're going to have. It'll really be cool, showing where I think the future will go and what we're going to try to do to position changes in the construction workforce, but it is struggling. So the Vantum panel is a low carbon panel. It is very similar to a wood SIP, except we've removed the wood. We don't want any wood on the product. Wood burns, wood chips, and if everyone's ever, to the gentleman at the first table there, talked about not being able to get the wood SIPs to fit, you're right. You got to work those things in and beat them, and that kind of goes against the speed of what you're trying to do. Whereas the Vantum panel is CNC'd as well, but it's a nanoceramic, so it's very light, very hard, and very accurate when it comes to fitting those together. So you can see the panel there. It's a good example and representation of really, as an industry, what SIP really does for the framer. It eliminates a lot of steps in the process by delivering a very high energy envelope. And we are about energy. Let's not mistake that. Vantum, and I'm sure SIPs in general, you're using SIP because you want to have low energy, right? You don't want to spend a lot on your utility bills. Vantum's whole model is about lowering the carbon footprint. When you build a 2,000 square foot house with our system, we have an 85% lower embedded carbon footprint. Our envelope is phenomenal. It doesn't mold, so if a house floods in our next session, we'll show you some examples. We've put, again, 3 million square feet of this product around the world. We'll be penetrating the U.S. here very quickly and be opening up factories, so you'll be hearing about us more. But we are energy focused, building housing at a very low carbon footprint, heating and cooling them on a dime, which SIPs in general will do if you use a good envelope.
All right, so getting to I think I've got some good photos here. So this is again from our build. You can see that the panels were loaded up on the left onto a trailer. Then we had teams showing up the morning of, moved all those panels around the foundation, which was done. The foundation had, I don't know exactly what the correct term is for it, but basically straps that were embedded into the foundation that then loop up over onto the panels. And they were able to basically get the framing up and airtight in 2 days. It's pretty quick. So the question I want to ask each of you is, we've got a group of builders here, which by the show of hands earlier, not many of them are dabbling in this yet. So the question is, where would you tell them to start? It may feel overwhelming to say, okay, I'm going to now build an entire house that is prefab. Is there ways to kind of partially get into this, to build part of the home using some of this? What is it that can get them some exposure and some comfort level, and maybe start getting some of their trade partners some more experience with this? So who'd like to start off?
Go ahead.
Where you start is at forums like this, where you're interested and you come and learn a little bit about it. You check out people's websites and call those companies, talk to their sales representatives, ask questions. Get some sort of a foundation. Where you want to go, what you want to achieve, and I think you just have to go for it. Doing like half a house with SIPs and half a house not is not the way to do it. I think you just have to try one. Get in there, do it. You don't have to change everything. You don't have to change your whole company philosophy and methodology. Just try one and see how it goes. Give it a chance. Sometimes, there is a bit of a learning curve, but if you can get through that first one and recognize the benefits and try and think of what you could do to improve some of the things that held you up along the way, the second house is always about twice as easy.
Do you agree, Jason? Is it kind of all or nothing?
It's a tough one. That's a tough one. I mean, with the Vantum system, I'll explain that. But I would think in general in SIPs, you could go build a she shed. If you want to understand how the components screw together, how you're applying the process of putting it together. But I think the real way to get into it on a normal SIP, not a Vantum, and I'll explain why, but a normal solution would be find somebody who's doing it now successfully. But I think you're right at the first table, and I didn't get your name, but it's all about training and understanding the kinks of it, right? There's always a facet to a trade. When you have experience doing something, you know how to do it the first, the second, the third time. It gets easier. So I would probably tap into one of their current builders that's doing it successfully. Maybe you can shadow them on a site and kind of learn and do a case study analysis and kind of understand it. And then I think you're right. You got to just do one. You got to do a house. The Vantum solution, we're a little different. If you're building 350 homes a year, reach out to me. I'll build you a factory and provide your product. That's what we look for as a developer and builder. We're looking for the throughput. We'll stand up the factory, we'll provide the product, we'll train, we'll help, and we'll be involved. That's where the Vantum model is a little different than what we're doing in the U.S. We're looking aggressively for builders that have the supply need. We'll stand the factory up, put in a 50% partnership with that builder who could do a take or pay order with us.
Ken, thoughts
different.
on how to start getting into it?
So there's been a recent trend in the industry for home builders to open up warehouses and stock some building materials because they lost faith in the supply chain to support them. And so you're going to be part of the batch and flow process of the flow of materials, which I think is a really good idea and a really bad idea, both at the same time. A really bad idea because I think that the core competencies of home builders is not managing materials and warehousing, inventory management, last mile deliveries to job sites, et cetera. So I think that there's a lot of opportunities for failure in that area. But I think it's a really good idea because it shows a builder's willingness to invest money in helping to improve the supply chain. And in panels is a very difficult thing to dip your toe into. I think you're both feet in or both feet out, and because this is what happens. This is what happened to some of the builders that I worked for. So we tried it. That's the word we use. We tried it. We didn't really, but we said we tried it. So what we did is we said, someone sold us on, hey, these panels are going to be great. It's going to shorten up your cycle time. It's going to reduce waste like you wouldn't believe. This is going to be a boon to your quality. This is going to be great. You can market this. Whole deal. And so we went in, we got started, we did a few houses, and it cost us a lot more money than a stick framing would cost. And then we had trouble justifying why we were going to spend all this extra money. Is quality better? Yeah. Is the availability good? Yeah, it was good. Yeah, everything was good. But when it comes down to it, it's really tough to justify additional dollars. So I have recently seen a video of a builder who I've been sworn to secrecy, so I can't tell you who they are, nor much details about it. But they just framed a house, two-story house, with windows, insulation, and house wrap, including the roof sheeted and waterproofed in 12 hours. 12 hours, start to finish. Now, they spent a lot of money doing it, and they know that they spent a lot of money doing that. But now that they have that process in place, now they're going to start refining it and getting that cost down. And part of the cost, which I'd love to hear you guys talk about today, is transportation. How to get that panel from where you make it to the job site. Because trucks and truck drivers' costs are just way out of hand right now, in addition to availability. But these builders know. Oh, by the way, the builder who swore me to secrecy, what I didn't tell him is that 5 other builders. So I now have 6 builders that have sworn me to secrecy that they're building houses with panels. I'm not sure why it's a secret, but they're pretty proud of what they're doing, and they're very excited about the opportunity to increase the capacity of the people who are building the houses. Someone mentioned trade labor as an obstacle. I agree with you. I have had wall panels and brought onto the job site, and the guys who are installing them were charging the builder the same price as if they were stick framing, which means you've got the wrong guys installing the panels, right? So you can install these panels with non-skilled labor, which cost a lot less than skilled labor, and so that's something that we had to get. That's an obstacle we had to overcome at our company too.
Okay, so to summarize, it's not that you can start building just part of a house with these, but perhaps, and I like the she shed idea, is maybe start doing some smaller projects. Say, we want to learn and to build some competency in this particular area. Maybe it's just a small demos. Maybe it's just a small look for an opportunity to partner with a nonprofit like Habitat in your area. And whether it's a small 1,200 square foot home.
It's a different process. It takes more thinking up front, but it's a simplified process on site, which is where it matters. Because that's where the skilled trades just aren't there anymore. And look, when 2030 energy codes hit, everybody out there framing the stickway is going to have to figure out how to meet those energy codes. Our system already is beyond the 2030 energy code. So we can heat and cool these things on a dime. I think there's a reckoning in the way we construct and build in the U.S. I construct and build and design all over the world, and we're finally getting to a point in the U.S. now where there's a lot of factors that are driving a lot of the big builders. I mean, Pulte and Toll have been doing it for a long time. They were very close to going volumetric in the 80s, right? They were nailing out 5,000 home developments through panelization. They were cutting edge. They really were, those two groups. So.
And for those who may not be familiar, when you use the term volumetric, what does that mean?
We'll get that on our
Yeah,
next
but I think
panel.
you can give us a sneak preview
So
now.
going beyond panels, where we take the panels and we now create an envelope, an airtight envelope, a 6-sided volumetric box, up to 16 foot wide in most states, 76 feet long in most states. That's where the real value comes, and that's where the industry is going. It'll take longer to get that. If you look at a McKinsey study, panels and off-site materials will grow at a much larger market share simply because of the complexity. It's much easier to put panels together. It is much harder to put a 6-sided box together, inspected off-site. We build hotels, we build Marriott hotels, we build apartments, we build townhomes in Vail, Colorado, and California, in Miami, so we can handle wind codes, earthquake codes. We can do all of that, but the next level above and beyond panels is taking that and now building boxes, where you're taking more trades away from on-site and into a factory. So that's where it eventually will go. It's just a matter of time and adoption.
So we'll see some pictures of the volumetric this afternoon at lunch, but that instead of just little wall segments, you're literally building a long cube, and then you're building larger buildings, stacking those cubes that are designed to kind of fit together, almost like Legos. All right.
Yep.
So over to Ken. You kind of started to touch on this, but can you go into some more detail from a logistical and a supply chain point of view, how these prefab components and panels can really be a game changer for a builder?
Supply chain management is about control. Let's get control of cost. Let's get control of materials so that you have adequate availability, but not too much in the batch because that inventory is expensive. So you want the minimum amount of inventory to supply an adequate flow of construction. To reduce waste as part of the reducing cost, and that you have visibility from start to finish of the products. Now, in our industry, our subcontractors don't want us to have that visibility. It's hidden from us, and they'll do a lot to block us. And there are some builders who buy their own lumber packs and hire framers to install. But for the most part, builders are doing a lot of turnkey, and they lose visibility to what's going on. So wall panels, collaboration with manufacturers of wall panels gives us more control over the process. So number one is control. Supply chain managers love control. We don't really have control, but we think we do, and it makes us feel great. 25 years ago, I was asking manufacturers, I was demanding that they make things that are easier to install. Well, that's no longer the need in our industry. We need them to make products that are difficult to install incorrectly. We've got to have them make products that are difficult to install incorrectly. And that's what our wall panel manufacturers do very, very well. So quality certainly goes up. And think about cycle time. Cycle time is an important thing in the construction process. You know how long it takes to manufacture a Lexus car? 5 hours. It takes them 5 hours to make a Lexus car. It took them 3 to 5 years to plan for that before the first car started its way on the assembly line. But once they got that planning completed, they now can make that car in 5 hours. Well, they don't actually build the car from the ground up. And I hear a lot of excuses for quality issues in our homes is, well, our houses are not made in factories. Well, could they be? And that Lexus car that goes down the assembly line, is that an assembly of pre-manufactured components. And those components are just assembled together. So in the house, I told you, about the house that was the shell completely built, including windows and house wrap in 12 hours. That's nothing. So in the Building Industry Association, BIA of San Diego, in the 1990s, we built a house in 4 hours. You can see the video online, the 4-hour house. So I encourage everyone to look it up. So we built a house, foundation to handing the keys over to the home buyer. We had an agreement with the building departments. We had building inspectors on site. It took thousands of people with staging material, very meticulously, people like this ready, the next trade contractor to go in, waiting to go in. So it's not realistic. We could do that and repeat that over and over again. But we built a house in 4 hours, from foundation to roof to handing the keys over to the home buyer. 4 hours. So if we look at cycle time and think, can we bring a 100-day schedule to 95? Oh my gosh, how are we ever going to take 5 days off the schedule? Is a ridiculous conversation, because the opportunities for improvement in our industry are huge, and the prefabricated area of that, I think, is a key component. And I don't know how we're going to do without it. And I talked about the labor force, and I tell you, I'm really worried about it. It does keep me up at night. It is not getting better. And for the long time, we've been able to rely on low-cost labor from other countries coming over to do that for us, and that is waning. So
Not in Texas.
I'm worried about it. Well, Texas, we have a steady flow right now. They're not all jumping onto our job sites. They're going to hotels.
Yeah, I mean, we're getting them in factories. I mean, I have relationships in Texas, so I mean, the labor is tough, but Florida and Texas have always been the best, lowest labor rates for construction in the industry, and that has dramatically changed over the last 5 years. You can't frame today in Texas for under $9, right? Just labor. It used to be $3. It's triple what it is today. So used to be able to build a hotel in 9 months in Texas. Today it's 18 months. And it's not the supply chain. That's not it. So it's people.
For those that are using the Vantum system, how has that changed? From 18 months, how quickly are they able to do a hotel?
Well, in the United States, our mission is to do volumetric, 6-sided boxes. We know from our experience that the more bang for the buck when we get to design the boxes and get all the finishes inside the boxes. That's appliances, the showers, the glass doors, the uppers, the lowers, really everything inside the corridor door. When you go into the room, it's complete.
You're going to see a picture of this tomorrow where you've got a crane taking this box, and you can see through the window, it's furnished. It's got everything in there, just literally.
Yeah, one of the cool things about that particular system, when we use the Vantum solution, we're able to get a lot more glass openings. When you look at the end of this box, the whole end wall is glass, the whole end. In the wood world, that'd be a 12-inch thick wall, and we're only going to get, probably a couple 28/48s in that end wall because of the structural loading. But with the Vantum, we can glass the whole thing, and you'll see that in the next meeting.
And I have a lot of experience with that. So a lot of the consulting I do is in Japan. So I go to Japan 5 or 6 times a year and work with the home builders there. And home builders, for example, on a bathroom, they don't build a bathroom the way we do. It's built offsite in a factory. Right. That's 6 sides with plumbing, electrical, all the finishings, all the tile, completely 100% finished. And then they crane it into place. Done. Bathroom complete. And so, prefabricated components, I think, is definitely where we have to go.
So we're definitely getting into what are some of the benefits of the prefab and kind of touching on some of those points. I know Jason's got a couple slides here. Let's talk about the cost savings and where do those cost savings come in once you're to speed? Because clearly you can see there's a little bit of an experience curve. There's going to be a little bit of learning. But once you're there, where do those cost savings manifest themselves?
Time, right? Time is money, right? On a large project we just did in South St. Paul, Minneapolis, that particular volumetric project saved about $2.3 million in just interest alone on the carry of being able to complete that project very quick. And that was developed by a big developer called Opus in the Minneapolis market. It'll win an award this year at World of Modular. Has a vertical parking lot inside of the apartment complex as well. It's really unique. It's called Avera. And so you're going to save on time interest, and then you're going to save on cost as well. We do 2 things in the volumetric world. We control time and we control cost. And how do we do that? We order all our supplies day one. We don't build the first box with every single piece of material in the factory because we can't, it would be like using the car analogy, building your car without windows, or what Ford experienced in the pandemic, building a bunch of F-150s without computer chips and then parking them in a field. Well, the cost of that doing twice goes against everything we do. So we control time and we control cost. The cost is by us ordering everything day one. There are no change orders. So we control the time and we control the cost. When we have great supply chain, OEM contracts with suppliers and vendors, and we're buying the rinse and repeat type of mentality because we do teach proliferation of SKUs as Lucifer in a factory. We're not building one-offs. It'd be like any manufacturing of any widget out there, and you throw something new in it every single time, never being the same, which is what traditionally most of the modular builders you may have come across out there do, right? That's why there's no scale or velocity. Velocity is key in driving down price. So we do those two things.
Okay, so cost, speed, what would you want to add? Or
Well-
expand on either of those?
Well, I guess it depends on the business model. We're not that volume type business model. We're doing less, and unfortunately, there are change orders in the industry that we're in. But in terms of cost, sometimes it can cost the same, but then there's bang for the buck. It's what you're getting for the same price. So when we get asked to compare our system with traditional stick frame, particularly stick frame, conventionally framed buildings, I don't know if there's necessarily a cost savings, but there's definitely a bang for the buck in terms of energy efficiency, in terms of speed. The material, sometimes the material cost can be slightly more, but then on the labor side, you're offsetting
Well,
it.
that's what I was going to say, is that if we're talking about, if I look at a wall for a house and what I'm going to spend on just the materials for that wall, you're saying the cost may be a little bit more, but when we look at the total cost of building that wall, when you add all the labor with those materials versus your solution and how quickly you can then stand those up, the combination of those two things together, the cost is less, correct?
Well, it can be less or equal to or less, but again, with better bang for the buck in terms of you still are completing that house sooner than you normally would. So there's got to be some value to that. The energy efficiency, the air tightness of that. And we keep talking about prefabricated wall panels here, but I should say that we don't do just prefabricated wall panels. We do complete prefabricated building envelopes, so including roof panels. So they're, depending on the design of the house, where you're eliminating trusses, you're replacing trusses with a vaulted ceiling, there could be rafters and beams. And so sometimes the price, it's not always a matter of the price always going down. It can stay the same, but again, what you're getting for that same dollar. So that's what I would say.
And I think I can't remember who mentioned it before, is that if you're using the same labor to set up the walls, you're paying more than you need to, because the experience needed to be able to assemble these modules doesn't require that much of experienced labor, and you should be able to harness some savings. Now you got to figure out how you're going to do that with your team.
And that is one of the obstacles that we find when we're dealing with the builders directly, or even homeowners who are asking their builder for an estimate to build their house with the prefabricated panels. A lot of the builders don't have a baseline to go on, so they basically look at it as just what they would do. It's a 3,000 square foot house, so it costs this much. And we see that with the framers particularly, and also the electricians, and that's a whole other conversation. But that is where the builders, once they've dipped their toe in and hopefully decided that they're going to try again, and they're going to put a team together that's competent and can refine as they go, over time, and not a long time either. The learning curve is fairly short. But once you have that right team in place, then you do have a better potential for actually saving some money. So the one-off might not save you. You're going to get better bang for the buck. You might not save much. But if you continue to do it, and especially for small developers who have just a few designs that they're doing over and over, in that type of situation, that's where you can really find the savings.
Okay, well, you brought up something that I don't think we've touched on, and there may be some questions out in the audience. Okay, let's talk about plumbing and electrical. If we've got these walls that are that have foam or some other type of core in them, how are we doing electrical and plumbing? So who wants to explain
I'll
that?
start out. I mean, it's real simple. We don't put plumbing in the exterior walls. We'll do a plumb wall inside to drop things down through a framed wall. On the exterior, we have cores, and I'm sure most SIPs will have a cord out in the EPS for your wires to come down from the top of the roof down into the walls and then out. But we typically don't plumbing in exterior walls in any market.
Which I think it leads to, you have to design from the beginning that you're doing this. You can't plan on just taking.
SIPs is a programmatic design. You know, when you look at it, each panel is labeled and marked. So you're following a grid, you're following a system, putting a puzzle together is really what you're doing. And I would think that, you know, on the job sites, you need one good seasoned project manager that knows what they're doing. The rest of the labor can be unskilled. Until you start getting in, if you're not doing volumetric, then you got to bring in your skilled trades for your plumbers, your electricians, et cetera. But one PM should be able to manage putting these things together once they understand what they're looking at and how it goes together. What happens when you get into buying and that wall's not seating properly? What do, right? There's certain things you can do to kind of help that process go a little quicker when you're dealing with wood SIPs, which is why I don't like wood. Burns and termites, et cetera. For the guy in Florida, you know, you got to build in concrete. So termites, unless you use a Vantum-style solution where you can get down into the dirt and it won't mold and it won't hurt.
So I like the idea that was brought up before of reaching out to others in your market or perhaps other markets that are already starting to use this and asking, hey, can we come see? I think what you'll find based on, I know I've got a smaller little experience set here, but those that are using this are passionate about how transformative this is and are very open to sharing. You're going to hear from Ted this afternoon at lunch, who's a builder in this area who's been doing this for 21 years. And he's super excited about coming in and sharing it with others. I think those that are doing this, because it benefits the industry, it benefits our communities, it benefits the world when we start talking about the carbon footprint, is that this is, I think an analogy would be like Elon Musk with Tesla, is that he's like, I want everyone to do electric. You know, I'm just showing this is the way to do it because it's going to benefit all of us the sooner that we can start transforming over to this paradigm.
I've never had an electricity bill ever go down in my life. I'm 50, you know, so I've never had the energy company call me, hey, Mr. Carter, we're low in your kilowatts per hour. It just doesn't happen. This is a great chart that we did, and we modeled it in a South Carolina, Georgia region. So it's a mid-climate region. It's not extremely hot. It's not extremely cold. We've tested and put our product all over the world, from the Atacama Desert, which hasn't rained in 300 years. Average temperature is 122 degrees daily. We've put the only one that I know of that's put a home in the South Pole, and it's still there. We did the Straits of Magellan Well Observatory. We've done universities, we've done schools, 111 schools in South America, with 49 charter schools more on the contract now. So we can build a lot of different things with the solution and with the envelope. So energy is really important, though. You know, what does it cost to heat and cool that home on a daily basis? Look what interest rates have done to, you know, you guys are all small builders. Any big major builders in here building over 500 homes a year? You know, so if you're not doing that, right, the smaller homes, you're less velocity. Interest rates affect your build and your deals, and so having a low energy consuming house helps your utility bills be next to nothing. I've got clients that get money back from the grid in the local power group, depending on where you're at in the country, because it's driven by states, and then some that don't pay anything or pay $10 a month for their utilities, which is a savings. I spend $500 a month in Minneapolis I have an old house. Can't build energy back out of that thing. There's nothing I can do. Just got to build new with the right system.
And we'll talk about it this afternoon as well when we look at the habitat build that we've done in our community in Manhattan, Kansas. It's a small home. It's a workforce housing home, 1,200 square feet. But with this type of envelope, the number of solar panels that we put on the top is less than what you would expect, but it's a net zero home. And when we bring developers in our area to see this home, and we tell them the cost, what it costs to build, even factoring in the real hourly cost for labor, even though Habitat has a lot of volunteers, the cost of the materials, and then look at the ongoing total cost of ownership, they're like, that can't be true. And I'm like, here it is. And so to be able to build houses like that at the cost, and I don't want to reveal the cost till this afternoon at lunch, but it is hard to believe, but it can be done. So as we move on to the fact that you kind of have to design differently when you're building houses, what are some of the real design needs? What are maybe some of the perceived ones that don't really apply? What needs to change in how you design a home when you're using this type of material?
It is a prefabricated system, so a lot of forethought has to go into it. You don't want to be changing on the fly. This is sort of a real limitation. It doesn't mean that you can't. With our system, it is wood and expanded polystyrene, so in a pinch you can change things on site, but ideally that's not what you want to be doing, and you don't want to be beating things in like was mentioned earlier. They should click together like a puzzle. We try to design them so that they're hard to get wrong. It is like a big ice cream sandwich puzzle what we do, and like any other puzzle, if the piece doesn't fit, it doesn't fit. You got the wrong piece. So with the panels being numbered and labeled, they typically only they only fit one way. And so in terms of that is a real design limitation in the sense that you really don't want to be changing things on the fly. In terms of a perceived design limitation, I think when you mention prefab or modular to a lot of people, they kind of have this preconceived notion of a kind of real boxy, it's okay, you can add maybe a little facade here and there and trim it out a bit, but the perception is that you really can't design the house in a way that you might otherwise do with say
the nicer aesthetics and
where you're a stick framed house, but that's not true at all. We can design a house. There really are no limitations to what we can do with the panels. So like I mentioned earlier, everything's cut on a CNC machine. And again, we do roof panels, wall panels, roof panels, and we can get into some really, really complex designs. Ideally, we wouldn't. We wouldn't have to. We'd be doing gazillions of boxes, but that's not what people want necessarily. So we do very complicated roof systems, walls. Pretty much anything that you could build stick frame, you can do with panels. Some designs are more suitable to SIP applications than others, granted, but they're really this perceived sort of notion of that a prefabricated or modular building is just going to be like a trailer. Yeah. It's not true. It's really not. It's unlimited.
So if we have builders out here like, okay, great, I know how to design my homes. I have no experience with being able to design something that uses these materials. Can you help?
Absolutely.
So will you can do the designs, or you can refer them to other designers who are familiar with SIP construction?
A little bit of both. We have designers in-house, and our sales team is very experienced. We can get in at the early stages of a project, at the preliminary stages, make suggestions. In terms of wall panels, you can do pretty much whatever you want. If you are doing a roof with panels, then that can, you're eliminating the trusses and you're replacing the trusses with a rafter or a beam type system. So it's kind of, SIP construction to me is more closely associated with post and beam construction. And so there's a little bit of thought to be done in terms of where where the support for the panels is going to be, the structural support. The panels are structural, but they don't float, so they have to sit on something. And we look at things like the snow load in the particular area that those panels are going to be built, the thickness of the panels, and how the panels are connected to each other to determine where any rafters or beams may be required. So we can help. We can also refer the customers to designers out there that are familiar with panels and engineers that can help with that. So yeah, we can definitely be a source to get and this is dipping your toe in it here.
Sure.
Call the salespeople, ask for some suggestions, and just take it step by step.
Other real or perceived limitations that should be brought up in this audience?
I would say it a little stronger than Dave. Save your money. Don't engage your architect to spend any money whatsoever, because undoubtedly it'll be wrong or have to be fixed. So find your solution partner. If it's the factory you're going to buy your SIP solution from, they will have what I call the nuts and bolts of the build. And you don't really need an architect for a residential home, generally speaking. So if you're doing a residential home, go to the factory, use their engineering and their architectural group, their CAD group, draw it out, then hand it to your architect. This is what I want. They're going to design. We usually design in waste thought process, right? Architects don't. They spend money. It's based on how big the project can be, dollar-wise. I know, I own an architectural firm, so I can say that. We want to design in a panel solution with minimum waste in mind. In volumetric, it's the same way. It's about saving materials, so you design to the panels. You can do the post and beam solution. You can do trusses and rafters. You can build this a lot of different ways. So when you have to understand what you're wanting and then work with the local provider that's providing your solution. And we can show you examples in the next round of product that I will show. You would argue all day with me that I didn't build that in a factory. So I look forward to that argument.
Anything you add to that?
A lot of builders pride themselves on their late-stage customization agility.
Well said. Well said.
And there shouldn't be a need for late-stage customization agility. Can you imagine going into the Lexus assembly line going, hey, I want louvers on my hood. Can you put louvers? No, I demand you put louvers. I'm not going to buy it now. I'm going to cancel my contract unless you put louvers in the hood. So Lexus is never going to do that, right? But we as home builders, we pride ourselves on our late-stage customization agility. I think that as you use more and more prefabricated products, we need to discipline ourselves to not, as a whole industry, we need to stop that. But build baby steps, take baby steps, and that is one of the disciplines that we need.
Okay. Next one kind of comes to you as well. We've talked about some of the logistical hurdles in distance. So what if I don't have someone who does these SIP panels that's nearby where I build? Does that mean I shouldn't even look at it, or how can that be overcome?
Cost-benefit analysis, right? So you need to do your cost-benefit analysis to understand, and I'm sure I still have those old calculations about how far you can be from the plant based on trucking costs before it's no longer feasible to do that. So proximity.
But my lumber has to come from somewhere else, so I'm paying trucking costs one way or the other, aren't I?
Yes, and so that's included in the cost-benefit analysis. So I have lumber here, and it travels this distance, and I have these framers. I have my prefab panels here, and it has to travel this distance. And as builders, we build over here, and then, a year and a half later, it's done, and we build over here, then we build over here. And so the challenge is that we now need that plant to be all over the place, or we have variable costs in logistics in getting the panels to the job site. And you just have to do that cost-benefit analysis to determine when it's no longer feasible, or find solutions to make it more efficient.
Okay. So Dave, you're here as a vendor talking to different builders. Mm-hmm. You mentioned kind of where your two locations are. If you're talking to someone from Rhode Island, is it kind of like, I'd love to help you, but it's just not going to work out for you? Yeah. Or do you feel like you have a solution that can still help those builders on the East Coast?
There are situations where, we have two manufacturing plants. One's in Michigan, one's in British Columbia, just up the road here. The one from British Columbia generally takes care of, pretty much Alaska down to California and a few of the western states. And you can imagine around Michigan, Midwest, but there is a limit. The farther away we get, the less jobs we're picking up. And sometimes, the ratio of the size of the house and the overall cost of the house to shipping can you're not going to send a shed to Colorado from Vancouver, but you might send a 10,000 square foot house. All of a sudden that the efficiencies or the ratio in terms of the material cost of the trucking aren't as bad when you look at it in those terms. But there's times, I would say, just while we're on this, logistics to hurdles, one thing with prefabricated panels is, sometimes the trucks, they're big and they take up a lot of space. When they arrive on the job site, you've got to be prepared for it. You're going to have a 53-foot trailer pull in and that, or more, or two. And you've got to be prepared to offload those panels, put them somewhere while you're installing them. The nice thing about the beauty of it is as you're installing them, that pile of panels, gradually gets down to zero, and you're left with nothing. There's no garbage. I mean, that's one of the real benefits of the prefabricated systems. But at the same time, when the panels do arrive, you really do have to be prepared for those. And in some cases, if you're living in Kansas, that might not be a problem. When you're living in Vancouver or British Columbia, Whistler, and you're building on the side of a mountain, that could be something that has to be considered.
The logistics of how you're going to do
logistics
that. I know Jason and I were looking at some video yesterday where they'll pull up with a trailer that actually has a crane built into it, and it's dropping it right where it needs to go. Anything you want to add to what's been said? I know when we talk about numbers-wise, you're saying, hey, if you're going to build a whole bunch of houses, I'll help build the factory right there where you want to be.
Yeah, that's our U.S. model. But to echo what Dave was saying, it's real simple. I think from the studies I've seen in the factories I've been involved with and the case studies in logistics, I'll start on the laydown where we just finished. You've got to have a laydown area, both volumetric and both for panels because of the trucks and the pooling and the loading, but it's a much cleaner site. Excuse me. Two, panels will travel easily 200 to 300 miles in the average market. Volumetric pods will easily transfer about 600 miles in any direction, easily in the market. I could also tell you, though, I'm building projects in Dallas and sending it all the way to Colorado. So it's really about cost. The more expensive your framing and your construction is in a market, the further this stuff can travel. Again, building something in North Carolina and sending it to Colorado is over 1,000 miles. Building something in Dallas and sending it to Edwards and Winter Park's over 1,000 miles. And this is being done right now as we speak. If I were to fly you to Colorado, I would take you to sites where all their housing is coming out of state. The factory that I built there for a client can't even keep up with the demand. So there's got to be more factories. There's got to be more solutions. We can't do it without you guys attending these classes, asking questions, and taking risk and getting involved.
And this is where I think that there's also an incentive for collaboration in markets, that if you're not big enough to justify this, getting more in your market that want to do this, you can all be ordering from the same factory potentially, correct?
Yep.
Yeah. All right, as we're kind of winding down here, how do we help sell these benefits to the customers? We've hopefully made a decent argument to the builders to say why this would be helpful for you in terms of cost, speed, carbon footprint. How do we get customers to say, hey, I want a prefab home? So what is the advice that we give for those builders to try to help sell?
I'll start and let Dave finish.
Sure.
I think there's a change of what the customer is looking for, and we can blame on part of this on the pandemic. But with our envelopes, we have very, very, very controlled air infiltration, right? It's about controlling air. When you can control the air infiltration, we can then make a home very comfortable, both clean for viral infections, which we have a much easier lift than an average stick builder with tons of air infiltration. So it's about home air quality. It's about energy efficiency and what you spend to heat and cool your water and your house and your heating air. Those are three big things. I predict in the next 5 to 6 years, people are going to be looking on Zillow and they're going to be seeing a HERS rating. They're going to be judging homes based on air quality, based on res check. How is my air? How much does this home cost to heat and cool? It's coming. It's coming, and it's going to be judged that way. So we've got to adopt it, and I think be sensitive to what the new buyer is looking for and being able to provide that. That's all I got.
Dave, Ken?
Did you?
The new buyers are savvy about energy efficiency, carbon footprints, things that we didn't used to sell in a home. And so this is an easy way to appeal to those attractions.
I would just say that a lot of the times, the customer for us is not the homeowner, it's the builder. So it's really a matter of us giving the builders, who would be our customers, the confidence to sell the benefits to the customer. And this is why we provide, I mentioned earlier, one of my roles at the company is I'm a site advisor. So for customers, builders, that they want to try, they want to dip their toe in, they want to do it, but they just need that sort of push. We offer this service where somebody can come out for a day or two and just kind of get you started. And once the builder has confidence, that builder can then sell the benefits of the prefabricated systems with confidence. And that's what they lack. The builders who have never done it, they lack the confidence to go and sit in front of a homeowner and say, hey, this is what we're going to do. We're going to build it like this. And when the homeowner says, really, I've never heard of that, and the builder can just fire right back and say, well, you're just not going to believe all, and really feel that confidence in the sell. So that's where I think from our perspective, we need to first educate and provide the confidence to the builders.
Excellent. So we've got 5 minutes left. We'll turn it over to some Q&A. We'll get the microphone out. What questions do you still have out here in the audience you feel like have not been answered so far, or maybe things that have been said here that made you wonder or question about feasibility of using this? I'll give you some time to think here. Here in the back.
So in regards to the plumbing and electric that we talked about, if we have 12 home plans that we repeat pretty regularly, what's the process to work with a panelization company to then take our architecturals and then convert them to be optimized using panels and then locations for plumbing chases, electrical chases, et cetera? What's the first step in that process?
I'll just start that and then let Dave, but you're doing what we don't like to do, but as long as you're flexible in some things, then that's the way to do it. I mean, if you've got 12 designs, this is what you build all the time, then just be flexible, meet with the producer, and you'll probably have to make some small concessions. That's about it. If you get into volumetric, it's a little bit more complicated because we're now dealing with transportation boxes. But in a straight panel solution, just hand that set over to your partner and work through the sets and get it optimized.
Yeah, I would agree. Typically, we avoid plumbing within exterior walls, prefabricated walls. One of the reasons, it's obvious what happened last year in Texas when it got cold and all the houses, all the plumbing blew up, and they look at the problems they had, and that's because that's what happens when you put plumbing in exterior walls. It's just not where it's meant to be. So keep the plumbing out of the exterior walls. The electrical within the walls is quite, we just build a grid into the panels. There's a 2 parallel or horizontal chases that go right around the perimeter of the building that you can run your wires that are unobstructed. You can put your boxes anywhere along those lines. We also put vertical chases typically, beside exterior doors. A lot of people, obviously, they want lighting outside. And we can run the electrical chases right up in line with chases if you do have roof panels that you can join up with. So it is different for sure, but we can move those chases around. We're not limited. It doesn't matter. We can add chases. These days we see more and more smart homes. So you have high voltage and low voltage electrical systems running side by side, but they need to be separated, so we can accommodate for that. Yeah, we're fairly flexible in terms of the electrical, but in terms of plumbing, you just keep it out of the exterior walls.
And I kind of feel like both you're being nice. Part of it is also, hey, you have 12 designs of what you've been doing before. Let's design you 12 from scratch that fit.
Yeah, we usually
So-
can meet all the same density requirements and looks and feels. It's just maybe a 6 inches here or a foot there, because again, we don't want to build a panel and waste it. So it's a 4x10, 4x8, 4x12 panel, whatever that panel size is, we try to build to maximize that full panel, so I'm not cutting down a 4-foot panel and throwing off a piece.
Yeah.
And so that's kind of what we do. And
I think
try
we're
to
more
value
like-
engineer that.
Yeah, and like I think for what we're doing different things. We're more slightly more custom, and we put in the electrical chases before we even manufacture the panel. We also do try to optimize, obviously, these 8x24 foot panels that we have, but in terms of electrical, we can be a little bit flexible with where.
Typically, all SIPs has a predetermined core for the electrical in it. It's just chased. So you pull the wire down every determined 2 feet on that panel, you know there's a chase coming down. If you're in Chicago, we're gonna have to conduit that, right, because of the fire rating. So every city and municipality may have a little tweak on top of that envelope, but every SIP I've ever seen or touched in its core has electrical inside the EPS cord out already for you to run.
Okay, we are at time. I need to make sure we get you to where you're supposed to be. But the wrap up here is that if you aren't seriously considering it, you should be. And you need to figure out ways to start gaining this competency, whether it's doing a little she shed, whether it's at least saying, hey, this year, 2023, we're going to go visit someone who's doing this and learn. But it's important. This is the future. It's coming. It's going to give you advantages, and it's the right thing to do. I hope you all come back for lunch, and we'll get to take this to the next level and look about how to go whole hog. So at this point, you've got your boardroom discussions on your schedule. If you can head to those, be there on time, and we'll see you at lunch. Who gets the book?
Chris,
That's gotta be
Chris, you got the book.
Give a round of applause for our panel. Thank you.